There are many forms that the equation of a line can take. One of the most common ones is the gradient intercept form, which we've already looked at, y equals mx plus b. Another one is called the general form. So that's this first one here, ax plus by plus c is equal to 0. Now, this is really important to know because a lot of our formulas from here on in use this information. So what you do is you rewrite the equation so that the coefficient of x is positive, the coefficient of y can be negative, that's fine, but x must be positive, and a, b, and c are all integers, which means whole numbers. So you get rid of any fractions, any decimals, and you write it so that the x is positive. You'll then use the numbers for a, b, and c in formulas further on. So the gradient intercept we're already familiar with, and the next one that we're looking at is the point gradient form. So you've got that here, it's y minus y1 is equal to m outside of x minus x1. So where this comes from, I'm going to show you now, and it's really quite simple. It's just like working out the gradient. But when we were working out the gradient, what we had was the point x1, y1, x2, y2. So what you were working out was the gradient between these 2 points. So what we're going to do here is say, well, to work out the equation of a line, instead of picking a second point x2, y2, we're going to pick a general point P. So any x, any y, because that's what the equation of a line is. It works for any x and any y. It tells you the relationship between them. So if you're looking at that, again, we go with the triangle idea, and the rise is the change in y. So that side there is going to be y minus y1, and the run is the change in x, so that's x minus x1. So using that and what we know about the gradient formula, well, we know that m is equal to the rise over run. So in this case, that is equal to y minus y1 all over x minus x1. And then we're just rearranging. So m multiplied by x minus x1 is equal to y minus y1. So if you are given a point that a line passes through and the gradient of that line, you can substitute it into this formula and work out the equation of the line. Now the next one you can see here is completely optional. It's called the 2-point formula. So y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. Now the reason that this is optional is because this point here, this y2 minus y1 over x2 minus x1, is simply the gradient, which we already know. We know the formula for a gradient, and if you don't know the formula for a gradient by now, you're in deep trouble and you need to go back and do some hardcore study. The y minus y1 all over x minus x1, well, that's what we just used in the point gradient formula. So instead of learning this whole new formula, what you do is use the two formulas you already know. If you're given 2 points, you find the gradient between the 2 points using y2 minus y1 all over x2 minus x1, and then you substitute that with either of the points into the point gradient form that we just talked about. So you are welcome to learn this formula. I know the formula and I use the formula, but you don't need it. And if you find memorizing formulas difficult, then don't bother. Just stick with your point gradient form and your gradient formula, and you can work out the questions using those two things as well. Okay, it's very important that you're able to use any of these equations and know when to apply them. So we're going to go through a few different ones here, and then you're going to be doing a lot of practice questions. So looking at the first question, we want to find the equation of a line with gradient of 2 passing through the point 6, negative 3. So we have a point, we have a gradient, so we are going to be using the point gradient formula. Okay, so every time I need you to start off with the formula that you're using so that they know exactly what it is you're doing. So once you've got your formula, you go y minus y1, so in this case that's negative 3, is equal to the gradient outside of x minus x1. So 6. Then you need to tidy it up. So y minus negative 3 is y plus 3. Expand your brackets on the right hand side, so we get 2x minus 12. Now it's up to you here which form you want to put your equation into. If you want to use the gradient intercept form, then what we need to do is subtract the 3. And you stop there. If instead you want to use the general form, we have a look at it. There are no fractions or decimals that we need to get rid of. 2x is positive, so we're going to keep the 2x on that side. So then what we're going to do is subtract the y. So to get it in general form, we're going to get 2x minus y minus 15, and that's going to be equal to 0 because we subtracted y from both sides. So the question didn't say which form you had to give it into, so either of those are perfectly correct and we'll get you full marks. So the box is just the 3 formulas. We're going to look at a couple of other different ways of asking it. So if they want us to find the equation of a line with a gradient of 5 and a y-intercept of negative 3, well, we've got a gradient, we've got an intercept. You're going to use the gradient intercept form right there because that's going to make life simple. So y is equal to mx plus b. So that tells us that y is equal to the gradient 5x, y-intercept minus 3. And you're done. Alright, so the next question, they want us to find the equation of a line passing through the points 2, 5 and 3, negative 2. So this is where I was saying you can either use your point gradient form or you can use your 2-point formula. I'm going to show you both. It's up to you which way you want to do it. So just watch and then figure out which way you'd rather do it. So looking at the point gradient, well, we have a point, we have 2 actually, but we have 1 point. We need to work out the gradient. So start with your gradient formula, so y2 minus y1 all over x2 minus x1, and then substitute in. So I'm going to use 2, 5 as my first point and 3, negative 2 as my second point. So the gradient is equal to minus 2 minus 5 all over 3 minus 2, which means the gradient for my line is negative 7. So now I have a gradient and I have a point. So I'm going to use the point 2, 5, and I'm going to substitute into y minus y1 is equal to m outside of x minus x1. So we use this formula in the first question. We just had to find one more piece of information before we could apply it. So y minus, and I'm going to use 0.25, so y minus 5 is equal to negative 7 outside of x minus 2. So again, just tidy it up. So I'm going to expand my brackets. Y minus 5 is equal to minus 7x plus 14. And if I'm going to leave it in gradient intercept form, I just need to add the 5. So minus 7x plus 19. And there's the equation for my line. Now if you wanted to use the 2-point formula, you're going to substitute straight into it. But again, I want you to start off with your formula so they know exactly what you're doing. So y minus y1 all over x minus x1 is equal to y2 minus y1 all over x2 minus x1. So substituting into there, we get y minus y1, so y minus 5 all over x minus 2 is equal to y2 minus y1 all over x2 minus x1. So then what I'd like you to do if you're going to use this formula is tidy up the right hand side because it's all numerical. So you want to come up with a simplified fraction. So y minus 5 all over x minus 2 is equal to, in this case, negative 7. Then you're going to multiply through by x minus 2 to get rid of the fraction because none of the forms of our equation have a y over x. So y minus 5 is equal to negative 7 outside of x minus 2. Let's stop and have a look. What you have there is exactly what we have over here. So they get you to the same point. You do exactly the same thing as we just did. It's just a new formula. So if you're good at memorizing formulas, memorize this, or stick with the others. Doesn't matter. You're going to end up with the same thing in the end. So y minus 5 is equal to negative 7x plus 14. So then y is equal to negative 7x plus 19. Two different ways of solving the same question. Pick your method, stick with it. Okay, so this question's a little bit tricky. We're asked to find the equation of a line with an x-intercept of negative 4 and a y-intercept of 3. So how do you think we might do that? Well, the first thing I want to do is just to draw a little picture so that we can figure out exactly what it is that they're talking about. They've told us that the x-intercept is negative 4 and that the y-intercept is 3. So we know instantly that we have a line with a positive gradient. We know what the intercept is. So you've got a few options here on how you're going to do it, but once you've got that picture, well, working out things like the gradient is really, really simple because the rise is 3 and the run is 4. So what's your gradient? Gradient is 3/4. That makes life very easy because I know what the gradient is, I know what the y-intercept is, I can go straight to my equation. So y equals mx plus b. Gradient rise over run, so 3 over 4x plus 3, and you're done. Now, if you wanted to use the 2-point formula, you could, using the points 0, 3 and negative 4, 0. You could use the point gradient formula and substitute in and work it out that way. You can use any of the forms that we were talking about to work this out. Now, the big trick here is figuring out which equation you need to use for which question. So in exercise 7.5, unfortunately for you, I want you to do all of them. It is going to take you some time, but you need to practice this. It's incredibly important. Good luck, and I'll see you in class.